All right, on page 723 today, we're going to talk about inscribed angles. And an inscribed angle has a vertex on the circle and sides that are chords. The measure of the intercepted arc is 1/2 the measure of the inscribed angle. This is all pretty important here. So what it looks like in a picture, if we've got circle A here, an inscribed angle has a vertex on the circle. So if we create an angle and put its vertex on the circle, point C is the vertex of angle BCD. We can say arc BD is the intercepted arc. This angle BCD right here, vertex on the circle, forms this arc BD. So if this angle measured down here is 50 degrees, we got to go back up here. I'm sorry, guys. The measure of the intercepted arc is we're going to say is twice the measure of the inscribed angle. I apologize. If this inscribed angle here is 50 degrees, then this intercepted arc is 100 degrees. When we're talking about an inscribed angle, it's different from a central angle. Last week, the central angle had its vertex on the center. So now the vertex of this central angle is twice as far from its arc, isn't it? All right. Last week, it was just the distance of the radius from the arc. Now it's the distance of the diameter from the arc. So the arc measure is going to be twice as big as the angle. The angle is going to be half the measure of the arc. Okay? So turn the page and let's take a look at example 1. And in example 1, we have a chord MN. I'm sorry, MP. Got point N, point O. We've got a 70-degree arc, and we got a 56-degree angle. And we're going to find each measure. First thing we need is the measure of angle P. So the measure of angle P right here, arc MN is its intercepted arc. So we can say the measure of angle P is going to be equal to 1/2 of 70. The inscribed angle is equal to half of its intercepted arc. So the measure of angle P is going to be equal to 35 degrees. In the second part of the question, they're asking for the measure of arc PO. And arc PO starts at P, goes directly to O. Its inscribed angle is this angle N down here, which is 56 degrees. So the intercepted arc is going to be twice as big as its inscribed angle. So arc PO is equal to 2 times 56. And 2 times 56 equals 112. Let's take a look at the second part of that example. Now we've got chord CD. We've got chord DF, chord CE. Arc DE is 98 degrees. And angle D is 40 degrees. We need the measure of arc CF and the measure of angle C. So when the lines start crisscrossing, using some colored pencils or highlighters can be very helpful. Because if we need arc CF, if we highlight it, arc CF, its angle, its inscribed angle is this angle D, isn't it? So arc CF is going to be equal to 2 times its inscribed angle, which is 2 times 40, which is 80 degrees. So here's our arc CF, it's equal to 80 degrees. Then we need the measure of this angle C. And if you extend this, the sides of these angles here, they end at point E and they end at point D, don't they? So angle C creates this arc, the green arc. And if the green arc is 98 degrees, then the measure of angle C is equal to 1/2 of 98 degrees. And half of 98 equals 49. Questions? All right, let's look at theorem 10.7 on the bottom of page 724. If two inscribed angles intercept the same arc, we're going to say if two inscribed angles intercept the same or congruent arcs, then the angles are congruent. If two inscribed angles intercept the same or congruent arcs, then the angles are congruent. So if we've got a circle, and in this circle, we've got an inscribed angle. CDA. That inscribed angle just formed this arc CA, didn't it? Well, what the rule says is that if two inscribed angles intercept the same or congruent arcs, so if we take this here and we draw in a second inscribed angle, angle B here forms arc CA as well, doesn't it? So we've got two inscribed angles. We've got angle D that forms arc CA. We've got angle B that forms arc CA. Well, in this case, the measure of angle D is going to be congruent to the measure of angle B. They both form the same arc. If they both form the same arc, then they both have the same measure. So angle D congruent to angle B. So if we just continue on this same picture and we get asked to find the measure of angle B, all right, and we're told that angle B is 3x minus 5, and angle D is 2x plus 15. The angles intercept the same arc, therefore they're congruent to each other, so the 2x plus 15 is equal to the 3x minus 5. We need the measure of angle B, therefore we need the value of x. So if we subtract 2x from each side of this equation that we just wrote, 15 is equal to x minus 5. Add 5 to each side. We get 20 equal to x. If 20 is equal to x and we need the measure of angle B, the measure of angle B is represented by this expression. So we take 3, substitute 20 for x, so 3 times 20 minus 5. So the measure of angle B is equal to 60 minus 5, and 60 minus 5 equals 55 degrees. Any questions up till now? All right, one more rule to cover. Bottom of page 725. We're going to say that if an inscribed angle intercepts a diameter or semicircle, then it forms a right angle. If an inscribed angle intercepts a diameter or semicircle, then it forms a right angle. And just put, well, we're okay. Here we go. So here's what the picture looks like. If we put point A right here, it's the center of circle A, and then we put a diameter through it, call it BC. I can go anywhere along this circle other than point B and point C and put a point. So let's go right up here. I'm going to put point D. If I connect D to B and I connect D to C, do you see how B and C are on a diameter? B and C also form this arc. And this arc is a semicircle. So here's what the rule says. If an inscribed angle intercepts a diameter or semicircle, then it forms a right angle. So this angle D intercepts a semicircle and a diameter. So look, it forms a 90-degree angle. That makes triangle BCD a right triangle. And all your rules regarding right triangles apply. In this case, angle B plus angle C equals 90 degrees. angle D plus angle B plus angle C equals 180 degrees. All right, the first rule is the two acute angles in a right triangle sum 90. And the three angles inside of a triangle always sum 90 degrees. Any inscribed angle in this circle that intercepts arc BC is a right triangle, forms a right triangle. All right, so let's flip the page and look at the top of page 726. And we don't have to draw a new drawing. We're just going to add to this one. We're going to make angle B here 9x minus 3. And angle C 4x plus 2. And we're going to find the measure of angle F. I'm sorry, we don't have an angle F. We're going to find the measure of angle C. So if you're asked to find the measure of angle C. Well, here's the rule we're going to use, is that the two acute angles in a right triangle sum 90 degrees. Well, here's one acute angle, and here's the other acute angle. So we're going to take 9x minus 3 plus 4x plus 2, and it has to equal 90. Then we're going to combine our like terms. So a 9x plus a 4x, we get 13x. Negative 3 plus 2 is negative 1. And it's still equal to 90. So if we add 1 to each side, then our 13x is equal to 91. And we're going to divide both sides by 13. And our x equals is equal to 7. Now that was just the first part of the question. So find the measure of angle C. Angle C is represented by the expression 4x plus 2. So we take 4 where the x is, we replace it with a 7 plus 2. So 4 times 7 is 28 plus 2. And 28 plus 2 equals 30 degrees. So the measure of our angle C is equal to 30 degrees. Any questions? All right, then your practice for today is going to be on, it's going to start on page 727. Through 26. And we're going to skip 21 and 22. Through 26, skipping 21 and 22.